Hi everyone, welcome to today's lesson. This is lecture 5. My name is Harmtedy. Today we're looking at exact differential equations. So an exact differential equation can be formed by directly differentiating its primitive solution, or its primitive, which is the solution, without any other process. So it's just by directly differentiating the equation that you've been given, or rather the solution that you've been given. So an exact differential equation always has this form. It has m and then dx, and then it has n dy. So this m and n are functions of x and y. Okay, so for it to be if you want to know whether a given differential equation is either exact or not, you simply have to find the m dy and the n dx, and then once you find this, if you find the m dy is equal to the n dx, then know to say the given equation, or the given differential equation is an exact equation. So like I said, this m is always a function of x and y. It can either be a function of x only, or y only, or both x and y. Same applies to n. So when you find the m dy, you also find the n dx. You have to check whether the two functions that you found are equal. If they are equal, then know to say the given differential equation is an exact equation. So this is what I'm just from explaining, where the m dy denotes the differential coefficient of m with respect to y, keeping x constant, and the n dx, the differential coefficient of n with respect to x, keeping y constant. So in other words, when you're differentiating this m, you have to consider y to be constant, and then when you're differentiating this n with respect to x, you have to consider you have to consider y as a constant. So I said when you're differentiating m, you have to consider x as a constant, and then when you're differentiating n, you have to consider y as a constant. So let's look at the method of how you can solve this. So the first thing you have to okay, this step has skipped something. It's saying the first step is saying integrate m with respect to x, keeping y constant. Alright, no, it's okay. And then second step, you also integrate y only. You also integrate with respect to y only those terms in n in n which do not contain x. So we're going to look at examples here. Yeah. And then the result of I plus the result of I2 is equal to the constant. Okay, so this is an example. This is example 1, and it says solve this differential equation. So remember what we say. The first thing is you differentiate m. And in this case our m is just this part, our n is this part, and then when you differentiate m, you have to differentiate m with respect to y. This is what we just from saying here. Differentiate m with respect to y, differentiate n with respect to x. So we differentiate m with respect to y. So this one will give you 20x to the power 3, 20x to the power 3, and then this one, sorry, we're differentiating m with respect to y, meaning we're keeping x constant. So if this is a constant, meaning this goes, we're not supposed to have 20m. So we're saying the m dy is equal to, so if we're keeping x as a constant, this will simply be a 0, and then so we're just going to differentiate these two terms with respect to y. So when you differentiate this with respect to y, we're going to have 6x squared, then you say y. Then when you differentiate this with respect to y, you're going to have negative 6 x, and then this is going to be y to the power 2. And then you also do the same on this other part here. Yeah, so you are going to differentiate this n with respect to x, keeping y constant. So you say dn dx, this will give you so when we keep y constant in this case, we're going to say this is going to be a 0, so meaning we're going to have this part which is going to be 6x squared y, and then minus, you're going to have this will be 6 minus 6x y squared. So when you look at this part and this part, are they the same? So if they are the same, just know to say the given differential equation is exact. So this is what I'm just talking about. You take out your m and your n, then after that you differentiate them. When you differentiate them, you're going to have this, and then when you differentiate this other part, you're going to have this as your solution. You differentiate m with respect to x, you're going to have this. So now, since this and that are the same, you can now say this given differential equation is exact. So now, since you know that it's exact, what follows now, according to the step number 2, you are going to differentiate this first part. You are going to integrate this first part with respect to okay, let me just show you this. So we're saying, since the m dy is equal to the n dx, the given equation is exact. And then from there you can say from there you can now integrate this m with respect to x, and then you integrate the other part, which is the n part. You differentiate it with respect to y, and then you only not differentiating, you integrate it with respect to y, and then you only integrate terms which are not containing x, meaning you only integrate the terms which only have y. So in this case, meaning you're just going to integrate this part. Okay, so this is what I'm trying to talk about here. So when you integrate this with respect to x and integrate this with respect to y, this side you have to indicate a constant when the integral of 0 is simply just a constant. So the integral of 0 is a constant. So this is what you are going to have. So apart from that, after integrating this part, you're going to have this as your solution. Then when you integrate this part, you're going to have this part as your solution. When you integrate 0, you're going to get a constant as your solution. So this is the answer. So the only trick part is this part. Otherwise, these other parts are just straightforward. Where you just get m, you differentiate with respect to y, you get n, differentiate with respect to x, and then see if what you are going to have, if your partial derivatives that you have are the same. So if they are the same, then the equation is exact. So now after knowing that the equation is exact, you now differentiate this you now integrate this m with respect to x, and then integrate this with respect to y, and then here you only integrate terms which only contains y, meaning the terms which do not have x. This is what happens here. And then from there you integrate 0, which gives you a constant. So let's look at the second example. So the second example says solve this equation. So solving this equation is simple. How do we do that? So remember what we said, you first have to make sure that your given equation is in this format, which is m dx plus n dy is equal to 0. So when it's in that format, what you do next is you simply differentiate this m with respect to y, you differentiate your n with respect to x. So when you differentiate this with respect to y, meaning you are going to consider x to be constant. So this is what you are going to have, So this is what you are going to have. This is your m, and then this is your n. Then when you differentiate m with respect to y, you're going to get this as your solution. You find the partial derivative of m with respect to y, because you are considering x to be a constant, so meaning this y, the derivative of this y there is going to be just 2x, because since this has x and we have 2x there, we consider that to be a constant. So when you differentiate this with respect to y, you are going to get this term there. When you differentiate this with respect to y, you're just going to have 2x. Differentiate 1 with respect to y, you get a 0. Same applies to the second part there. You differentiate you differentiate this sine x squared with respect to x, and then differentiate also this with respect to x, even that with respect to x. And when you differentiate that, this is what you're going to have. Remember, when you're differentiating this, you simply first differentiate your u there, and then when you differentiate your u using chain's rule, you are going to have 2x, and then 2x, that 2x multiplied with the derivative of sine u. What is the derivative of sine u? It's cos u. So our u in this case was x squared, so we're going to have 2x cos x squared using chain's rule. So I was just differentiating this part, this first part here. Then when you differentiate negative x squared, you have negative 2x. When you differentiate 3, you're going to have 0. So after differentiating, you can now check your solutions here. Check if they are the same. So if they are the same, then note to say the given equation is an exact differential equation, meaning you can solve it using the method that we are just from learning how to solve the exact differential equations. Yeah. So since we know now to say these are the same, we can now conclude to say this given differential equation is exact. Now if it's exact, what is our first step? We're going to differentiate this, we're going to integrate this with respect to x, and then we also integrate the terms in m, in n. We differentiate, I don't know why I'm mentioning differentiation. Okay, we integrate the terms in n with respect to y, and then we only integrate the terms that contains y. But when you look at this n, our n here, or rather when you look at this part here, you can agree with me to say we don't have any y here. So meaning we are just going to forget about this. We're only going to differentiate, we're only going to integrate this part. That's all. So in this second part, you are only allowed to integrate the terms which only contains y. That's all. So okay, let's see what we have. So since we know to say the m dy and the n dx are equal, hence the differential equation is exact. So now since it's exact, we can now follow the steps. So we're going to integrate m with respect to x, and then in this second part we'll only integrate the terms that do not contain x, meaning the terms that only contains y. So when you integrate this, okay, so when you integrate this is what you're going to have. And then in this second part, I said we're just going to cancel it. There's a constant 3 here. I never just saw it. Yeah, so we're just going to integrate this 3 with respect to y. So this is what you're going to have. Then when you integrate, you're going to have this. Yeah. So after you've done all the integrations, you are going to have this. So here they're just trying to simplify the expression so that it's easier for them to integrate. So in this case, they decided to use what is called t substitution in order to integrate this part properly. But the other two parts are just straightforward. Integrating this with respect to y, straightforward. With respect to x is straightforward. This one with respect to x is straightforward. This one with respect to y is just 3y. Okay, so now integrating this part, they decided to use t substitution. T substitution, if you don't know how to use t substitution, you can go in John Bed, or you can request for a video. I think I've made a video on that on my YouTube channel. Okay, so this is how you solve such an equation. So just after the integrations, the final answer that you get, that's the answer. Like when you look at this part, we have y sine x squared minus y x squared plus x plus 3y. Yeah, so the only trick part is on the part of integration. When you're integrating, so you integrate the first part with respect to x, and then the second part you always have to integrate the terms that only contains y. That's all. So when I say the term that only contains y, it's a little bit confusing, but the best way to put this, just say the terms that do not contain x, so that you also include the constants. Okay, so meaning here you just integrate the terms that only contains x. That's all. Alright, so thank you very much for watching today's lesson. There's an exercise at the end. You can do it at your own time, and then find time, and then send them on my WhatsApp line. Yeah, you send them to my WhatsApp line, and then I'll check through, and then I'll see if you've gotten the question correct. I'll do assist. Oh, sorry, I think this was an example. I'll see, maybe I'll put another question. Yeah, I'll change this question. So you can do these questions, there are only 2. Then send the solutions to my WhatsApp line. I'll check through and see if you're going to make any mistake. I'll correct you as soon as possible. Yeah, so see you in the next lesson.